Hello everyone, my name is Himanshu Sharma, and in this video I would like to share my observation with native images of a Spring Boot application and why they might not be a good fit for your use case. So let's get started. For this we need a simple Java project, and I am on the Spring Initializer website, and what we are going to do is we will create a simple project which will be a web-based project, and it's going to interact with our Postgres server, and for that I'm going to use the Spring Data JDBC, and we need Postgres driver, and yes, and one more thing we need is for native we need the GraalVM native support developer tools. So for this you need to have your GraalVM setup on your machine. And now let's name the group as Himanshu and name the project as native JDBC. And we're going to go with Maven. So let's see how our POM XML will look like. So let's click on Explore. And here we are getting the data JDBC. We are having a starter web and we are getting the PostgreSQL. And in the plugins we are getting the native Maven plugin. So that's all we need for this project. So just go ahead, generate it and open it in your favorite IDE. So I have this project available, so let me get back to the IDE over here. So let's navigate our project. So this is the main application class. We don't need to make any change over here. I have created one student Pojo and I have annotated the ID with @ID using the data annotation. Then I have couple of fields: name, city, country, phone, and the rest all are getter setters, nothing else. On the repository side I have created a student repository, and here I have injected JDBC template, and then one single method find all students, and what it will do is it will query all the records in the student table. That's all. And now in the controller I just have a get students get mapping. That's it. So let's run our application. And before that, let me show you my DB setup. And even before that, let's go to the application YAML file. So these are the entries I made in the application YAML. We only need the database URL, the username, password, and I have specified the schema as native. And then I put the logging level to make sure that the queries are getting executed. And then the server port, and these are all the entries we need. So on the database side, let me head it over here. So you can see over here I have a schema as native, and under this native I have a student table, and if I query the student table I have these 5 records. So let's start our application, and for that we will go to IntelliJ native Java application. Let's run our application, start it, and let's hit it using Postman. So I'll go here, I'll use the get request, and this is how the responses we are getting. So this is a simple application. And just to summarize, a simple application which is hitting the Postgres database, fetching few records from there, and we are exposing one get endpoint, get students. No further complexity, that's it. Now head back to our application, and what we are going to do is we will be running 2 instances of this application. One using the native image and another one using as a jar. So for that, what I'm going to do is, let me stop my application from here. Okay, and now let me head it to the terminal. And in the terminal, I will navigate to my project location, which is native JDBC. You can see over here, this is our project. So what I will do is, first, sorry for that. What I will do is, I need to make a native image, and let me show you one thing first. My Maven is configured with the Java having GraalVM pointed. So my Java default is also the GraalVM. Okay, so let's run the app. Let's create the native image. And what I'm going to do for that is, once you have that native dependency installed, you have a native profile. So you can directly type native and compile. That's it. So this is the command, mvn-p native compile. It will create a build and it will create an executable. So I'm doing all this step on a Linux machine. I'm using Pop OS in this case. I tried to do the same thing on the Windows machine, but I'm facing a lot of issues while creating an exe executable for Spring Boot application. And over there, the other option I have is to create the Docker images. But I want the raw power of my machine. I don't want to put any other Docker layer in between, so I'm using the Linux setup right now. And in Linux, I don't get any issue while creating the native images. It's pretty fast and pretty easy to set up. So currently our image is in progress. You can see over here, it's total 7 steps, currently on 6th step. And let's see, it might take a bit time while creating your native image, and once it's done, then the boot up speed and everything for the native image is fast. Sorry to say everything, but yeah, the boot up image, the boot up time is very low in your native executable. So what I have to do is, I'll go to target folder, and now if I list down the contents over here, you can see this native JDBC. So this is a .sh, like for Linux, it's a native executable. You can directly run it. So I'm going to run this one, but for that, first I will do is, I will just copy it somewhere. So what I will do, I will put it, let me delete these two. I will go to my folder target. This is the executable which we just created. I will copy it and I will put it on another location. And let me tell you why I need to do that. Because I need to create a jar from the same code base, and to keep everything as close as possible, I would like to run it with a different port, and that's the only change I am going to make. And now I will get back to the terminal, and here I will say mvn clean compile install. That's it. Now it will do a clean build. I am getting the same code, but now the service will run on port 8181 if I trigger this jar. So let's go ahead and get back to that folder target and copy this jar. So I have pasted it over here in my workspace folder, I have the executable and I have the jar. So let's clear our terminal and let's head back to the workspace folder. Here we go. So native JDBC is our native executable. So let's run it and you can see the boot up time. It's 8080 and it took 0.052 seconds. That's it. It's running right now. I mean that's the beauty of the native executable. Now let's open another terminal. I'm on the same workspace folder. Now I just need to run the jar. So what I will do is Java jar and I'll say native set. I think you got that right. I mean this is taking time. So it took 1.305 seconds. I mean the log printing was way slower as compared to the executable one. So our executable is on 8080. The native image is running on 8080 and it started in 0.05 seconds. And our jar is running on 8181 and it started in 1.3 seconds. That's a huge difference. So now let's see how it responds to our GET request. So I have a tool installed on my machine which is Apache Benchmark. You can set that on your Windows machine also. I can show you here. It's Apache Benchmark. You can search it on Google and see how it can be installed on Windows or Linux or whichever operating system you are working on, Mac. So this is the tool. It helps me in testing the API. You can put a load. You can test your API using this Apache benchmarking tool. So let's get started. And here I'm saying I need to run. Okay, before that, let's make a quick curl command for both the APIs to make sure they are working right. So let's say 8080 get students. I should get a response, right? So yeah, we are getting it. And now let's do the same for the jar one. And yes, both are working. So on to the benchmarking. Apache benchmark. I say ab-n. I'm saying let's make 100 requests and I have like 2 concurrent users and I would like to hit the native image first. So I'll say get students. That's it. And let's see how much time it took. For 100 requests for 2 it took like 0.020 seconds. Okay, let me try one more time. So I'm hitting the exact same request. I'm still on the native executable. And again it's same 0.025 seconds. And again it's nearly same 0.034 seconds. Now let's do the same thing for our jar version. And you see it's taking 0.10. See the difference, 0.10 and 0.0. So far it looks like executable is winning the race, but here's the catch. What I'm going to do is I will make another request, same request, onto the jar version one more time. Did you see the difference? 0.080 and 0.105. So in the jar version I made 2 requests. First request took 0.10, second request took 0.080. Okay, while in the executable one it was always consistent, 0.034, 0.025, 0.020. So that means even though executable is fast in speeding things up, it seems we are losing the optimization in the executable version. So let's increase the size of our test case, and instead of 100 I will say let's make it 10,000. Okay, and I'm saying 10,000 requests for 2 concurrent users, and I'm hitting the native image, and it took me 1.795 seconds. I will do the same test again 1.875 seconds, so difference of 0.1 second between the two. Again the same 1.8. so every time it was like 1.75, 1.8, so round about 1.77 seconds we are getting. Now let's change it to the 8.1. okay, the non-executable one, the jar version. Let's hit it. First time it took 2.689 seconds, which is way more than what executable is giving, but now I hit the same request again. See, we are getting below the executable one, like it is faster than the executable. I got the response in 1.47 seconds. You see, 1.359 seconds, 1.37 seconds. So it's not like every time you hit the request it will get low, it will get saturated after a certain time. The point here is, like, even though the first request is taking time in the non-native version, in the jar version, but in the jar version you are getting the optimization, you are getting the optimization on the concurrent request. If the same request is made again, they will be faster, they will be optimized one. So that's why whenever we are making the multiple requests, so we are getting a lower time as compared to the previous one. So let's consider this as a 1.34 as the last figure for this number. And what was the native one? Let's run it one more time, because we see that native always remains consistent. Whatever the time you are getting the first time, it remains same. So see, 1.9 seconds and 1.3 seconds. See, so I mean, for now it looks like that though we are getting the boot up speed in the native version, but we are losing the benefit of optimization. Might be there are techniques out there which somehow help this thing in the native version. I'm not sure yet, still investigating. But yeah, as per this observation, it looks like that the jar version have the optimization benefit. So considering this, I can say, like, if I have a use case where I'm expecting some kind of recurring requests is expected, some kind of my flow is going to be common in my request, in my processing, then jar might give me a better result in the long run. And on the other hand, for the native, it looks like if I need to run something very quickly, which is very time sensitive or needs to be done like once in a while, or it will always be a very dynamic data, and every time I'm getting something new or some new flow, then it looks like the native is taking the advantage because its boot up is fast. So let's take an example, like if you are using some kind of cloud resources which you want to trigger based on certain condition, and then you want to use them at the minimum possible time. So in that case, your native executable might help, because its boot up time is very fast. It will take less time to boot up and run the application. perform your business logic. So that's all in this video. That's what I was working on, and I think I feel like it needs to be shared. So yeah, so that's all in this video. Thanks for watching. Thank you everyone, and if you have any suggestions or any feedback, please let me know in the comment section. Thank you and have a nice day.